Okay, so welcome to this tutorial on momentum. This will just serve as an introduction for the Regents physics class. So first of all, momentum, we think of it as a property of moving objects. You can think of it definitely as inertia in motion, meaning that any object with mass has a certain amount of inertia, but a moving mass not only does it have inertia, but it also has momentum. And it depends on mass and velocity. And we are talking about the vector quantity of velocity and the scalar for mass. So we basically take mass and we multiply it by velocity, and that is equal to momentum. Now, the symbols that we use for these three quantities, you know mass and velocity, so mv on the right-hand side. The symbol we use for momentum is the letter p. So we have p equals mv. And since velocity is a vector, and momentum is also a vector, and the direction of that vector for momentum is the same as velocity. In other words, that if we have a block that is moving in that way, so its velocity vector is in that direction, then its momentum vector is also in that direction. So if we have a car that has a mass of 2,000 kilograms, and it's moving with a velocity of 5 meters per second, the question would be, what is its momentum? So we know m is equal to 2,000. The velocity is equal to 5 meters per second, and we want to get p. And so we know p equals mv, and so we get the 2,000 times the 5 meters per second. So we get 10,000. And if you want to think about units, we had a kilogram and we multiplied it by a meter per second. So the units for momentum are just that, a kilogram meter per second. So the momentum of this car is 10,000 kilogram meters per second. So let's actually go back and put that on our previous page here. The units, kilogram meter per second. I'm going to actually box these two things. All right, another quick example. If we were traveling at not 5 meters per second, but at the new velocity, okay, so I'll call it v prime, is now 10 meters per second. You could do this in a variety of ways. We want to know what p prime would be. But let's do this from a proportional standpoint. What we're saying is we're keeping mass the same, and the 10 meters per second, my new velocity, is twice that of my previous velocity. So it's 2 times the original velocity, so my p prime is going to be 2 times my original momentum. So if the original momentum, so p prime equals 2 times the original momentum, so my new momentum is going to be 20,000 kilogram meters per second. So if we have two objects that let's use that car. So the car is moving at that 5 meters per second, and it's got a mass of 2,000 kilograms. But we have another object, another vehicle, a bus, and its mass is 10,000 kilograms, moving at 1 meter per second. If we wanted to figure out which one had more momentum, they would be the same. And so kind of a nice takeaway from this is that two objects that have unequal mass can still have equal momentum as long as the smaller mass is moving fast enough to compensate for the larger mass of the second object. The next term that we want to define is what we call an impulse. Okay? An impulse, by definition, is a change in momentum. So we know that we have a change in P, and that is equal to our impulse, which we give the letter J for. Okay? Now, it's really important to stress here that the impulse is not equal to momentum, but it's equal to the change in momentum. Okay? So units-wise, that is the same. We could write the units for a change in momentum to be the kilogram meter per second, but often, as we will see in class tomorrow, we express it as a Newton second. And if you recall that a Newton is a kilogram meter per second squared, and we're multiplying that by second. And you can see that we get the units on the left-hand side equaling the units on the right-hand side. All right, so that's all for now. We'll take a look at this relationship between impulse and change momentum tomorrow with a nice little mini lab. All right, thanks for listening. Have a great night. Bye-bye.